Okay, boys, so let's work through these. Rule for f of g of x, so substitute g of x into f of x, so that's fairly straightforward. F of g of x is simply equal to natural log of 2x plus 1. Doesn't say anything about domains and ranges, so 1 mark, that's all we need. Why the function f of g of x does not exist. So to exist, we need the range of g to be a subset of the domain of f. So state that, okay, and then work out the correct values. The range of g. The range of g what is the range of g? The range of g is R. I'm not sure about this, boys. That's R. The domain of f in this case is also R, so true. I wonder if that was a typo. I wonder if it's been copied down wrong. G of f of x would require the range of f to be a subset of the domain of g, and the range of f is R. The domain of g is 0 to infinity, which is false. So maybe that's a mistake in the question. Not too sure about that. I reckon it might need to be over here, g of f of x. All right. All right, explain whether or not it exists. So I've just done a bit of that. So what do we need? We need the range of f, subset of the domain of g, the range of f, the range of f. So quick sketch of that graph is x squared plus 2 from 0 though. So that's roughly what our graph looks like. So we need from 2 to infinity has to be a subset of r plus, which is 0 to infinity, which is true, therefore exists. Explain whether or not the inverse function g inverse exists. So e to the minus x, what does that look like? E to the x is this one, which means e to the minus x is that. Since 1-to-1 function, yes, it exists. Find the rule and the domain for the inverse function. All right, so again, rule, swap x and y, f inverse, where's f? Make sure I've got the right graph here. F inverse of x, so we've got x equals y squared plus 2, y squared equals x minus 2, y equals plus or minus x minus 2. So therefore, f inverse of x equals plus or minus the square root of x minus 2. So to determine whether or not we're going to, which of those we're going to use, let's consider the domain and range of f. The domain of f has been given to us, which is 0 to infinity, which means, where are we going to put that? We'll go here. The range of f inverse is going to be from 0 to infinity, which means it's going to be the positive values, which means f inverse itself is going to be the positive square root of x minus 2. And we've looked already up here when we did a quick graph sketch. The graph of that is from there, so the range of f is going to be from 2 to infinity, so the domain of f inverse is 2 to infinity, which sort of ties in there with that, doesn't it? From 2 to infinity gives us a positive value in the square root. Okay, so find the rule, check domain, yes. Oh, we didn't have to state the range, so we didn't need the range, but we'll put it in there anyway. Let's keep moving. Write down the maximal domain of the function. So straight away, I need x minus 2 to be greater than 0, so x has to be greater than 2, so my maximal domain is from 2 to infinity. Whoops. Just thinking, check our brackets, and the natural log of 0 is undefined because that's my asymptote, so it's strictly greater than 2. Right, find the exact values on the points of intersection of these graphs. All right, so points of intersection, let the graphs equal each other. So we get e to the minus x has to equal, e to the positive x has to equal 6e to the minus x minus 1. All right, so if you like, let's go with the e to the x plus 1 equals, it's the equivalent of writing that, isn't it? So then, 6 on top though, multiply by e to the x on both sides. Now I get e to the x squared plus e to the x minus 6 is equal to 0. So that's actually a quadratic-like expression. So if u was equal to e to the x, u squared equals e to the 2x. So that's the same as u squared plus u minus 6 is equal to 0. U minus 3, u plus 3, u minus 2 is equal to 0. So u equals negative 3 or positive 2. U is e to the x. E to the x is equal to negative 3 or e to the x is equal to 2. No solutions there. Or if we want to solve that, log base e of 2 is equal to x. Okay, so there's my solution. Exact values of the points of intersection. The exact values of the points of intersection. So I'm guessing we probably should get the y value too. Just trying to think that through. Y equals e to the log base e of 2, because that's the y value or the x value, and e to the log base e is it's that f of x, f of f inverse of x, so they cancel, leaves me with y equal to 2. So the point of intersection, natural log 2, 2. Okay. Solve the following for x. Divide by 2 first, e to the x plus 1 equals 3. So now I've got the log of the exponential on the left. Log base e of 3 is equal to x plus 1. X is equal to the natural log of 3 minus 1. All right. What about the next one? Let's just slide it up a bit. What do you want to do here? So they're all the same base log. So what if we get that as log base 5 of x squared minus log base 5 of 3x is equal to 1. Subtract log, so we divide. So log base 5 of x squared over 3x is equal to 1. So now my base is 5. 5 to the 1 is equal to x squared on 3x. So I get x squared equals 15x. So if I factorise, I've got x squared minus 15x is equal to 0, x minus 15 equal to 0, x is equal to 0, or x is equal to 15. X is greater than 0, therefore x equals 15. All right. What's next? F of x equals the natural log of x. Show that f of u minus 2 f of 1 on v equals f of u v squared. All right, so let's substitute those values in. Make it a bit bigger. All right, so f of u equals the natural log of u. F of 1 on v equals the natural log of 1 on v, which equals natural log of v to the minus 1, which equals negative natural log v. So, keeping that in mind, well, let's multiply that by 2 then, eh? So 2 times f of 1 on v equals negative 2 natural log v. So there's my equation, f of u minus 2 f of 1 on v. That's equal to f of u, which we said was natural log of u, minus 2 times f of 1 on v, which is negative 2 natural log of v. So that's equal to natural log u plus natural log of v squared, which equals the natural log of u v squared, which is as required. Oops, not quite. So natural log, which is equal to f of u v squared, which is as required. All right. Find the inverse function. How often do we do this? Find the inverse function. That means I need to put x equals e to the y plus 1 minus 2. X plus 2 equals e to the y plus 1. Base, there's my base. E to the, oops, let's just rub that out. There's my base, so we need to get into a log form. Log base e of x plus 2 equals y plus 1. Y equals the natural log of x plus 2 minus 1. It's an inverse function. G inverse equals the natural log of x plus 2 minus 1. Check the question. Didn't have to find a domain or range or anything, so there's our answer. Question 8. What have we got? Solve, similar to one we did earlier, isn't it? So the bases are all the same, so we can look to manipulate. So what if we get them all on the one side? Log E3 plus log E x squared minus log E 4x equals 0. So log base E of 3x squared over 4x equals 0. So use that base transformation. E to the 0 is equal to 3x squared on 4x, which means e to the 0 is 1. So 4x is equal to 3x squared. So what if we go 3x squared minus 4x is equal to 0. X out the front, 3x minus 4 equal to 0. X is equal to 0 or 4/3. Solve for x. So either of those answers are reasonable. So done. Last one. Again, let's find our inverse function. How often do we do this? Okay. So let's have a look. Find the inverse of. So let's write it as x equals 1 minus e to the 2y minus 1. So take the exponential across and bring the x back. So we'll go e to the 2y minus 1 is equal to 1 minus x. So there's my base. E to the 1 minus x is equal to, I've done it again, log base e of 1 minus x is equal to 2 times y minus 1. So that's a half. All right, natural log of 1 minus x is equal to y minus 1. Y is equal to a half natural log 1 minus x plus 1. So it's not y, it's f inverse. So f inverse is equal to a half natural log 1 minus x plus 1. Find the inverse, nothing about domain and range, so we're done. Good luck. Good luck.